All right, cool. I'm just gonna get started. Um, Agenda for today, we're gonna be number one, announcing the winner of the giveaway that I was hosting since last week. And after that, we're gonna be doing a system design overview of an interesting system. That's a system that's actually made the news this week. So yeah, we'll be doing a system design of Deliveroo. For those of you that don't know what Deliveroo is, it's a food hailing service in the United Kingdom. And yeah, recently they were acquired by DoorDash for a huge sum of money. So yeah, when I saw the news, the first thing that came to mind is obviously the tech side of it. So we'll be doing a quick system design of Deliveroo. Obviously, I'm not going to be able to design their system to a T, but I'll be giving my attempt at a system design overview or like an architecture of Deliveroo and all the services that I think they may have. Obviously, the real implementation is going to be very different to what you guys see today because, I mean, it's such a big system, right? So obviously, I'm not going to get it right, but hopefully, what I explain throughout this live stream should be beneficial and should give you some flavor of understanding of how systems like Deliveroo or like Uber Eats work. And yeah, we'll be talking about different topics as well. So yeah, so first things first, I just ran the live stream draw, and the winner of this live stream, oh, the giveaway draw, sorry, not live stream draw. The winner of the giveaway is Mohammed Abbas. So I will be messaging you personally, and yeah, congratulations. And I'll be running the second giveaway sometime soon. So yeah, if you guys do want to win the next prize, then do what the giveaway post says. Like, comment, share, and you'll be entered. But yeah, there's this weird thing with LinkedIn where I don't think doing giveaways is even allowed because I posted a short or like a reel on my LinkedIn announcing the giveaway, and that got taken down. So I'm probably gonna throw up another post for the second one and try and not draw much attention to it because I don't want LinkedIn to ban my account. So yeah, cool. So I guess we'll just get started. Let me share my screen. I think every week I say I'm gonna have a presentation ready, but obviously with work being so busy right now, I just don't find the time. But hopefully you guys will still find this beneficial and yeah, cool. So I guess we'll start off with defining the problem. So for those that join later, let me zoom in. It's a bit too big, but Deliveroo system design. So for those that are international or don't know what Deliveroo is, the equivalent in the United States is probably DoorDash. The equivalent in the Middle East is probably Careem. The equivalent in North Africa is this other app called Glovo. So yeah, Deliveroo is the same. I'd say the system design is probably similar across the board. They're probably using the same technologies or same principles throughout. So hopefully this will translate pretty well to those other systems. Cool. So let's start off with some functional requirements and define the problem. So first and foremost, let's actually do this here. So functional requirements. I'd say the first one is users can browse restaurants and place orders. Browse restaurants and place orders. So that's pretty simple, right? I mean, users can see restaurants on the app. If they see something they like, they can place an order. That's like the most functional of functional requirements for Deliveroo. So that's number one. I think number two, riders or like delivery drivers can receive orders I before E except after C. I still use that to this day. Receive orders, pick up food, and deliver it. So that's functional requirement number two. I think another one is restaurants receive orders. I keep making the same mistake. Receive orders, uh, accept them as well. Accept orders and prepare food. What else is there? There should be some kind of real-time tracking. Real-time tracking for both users and riders, so that users know where their food is, how long it's going to take, and riders know when to go pick up the food, basically. What else is there? I guess if I'm a user and I place an order for some food, I'd like some notifications. So a notification, some notifications for each step in the process. What else is there on the app? So I browse restaurants, I choose some food, I place an order. Oh yeah, some kind of payments processing, and then all the other stuff that comes with payments processing, so stuff like refunds and maybe discounts as well. Cool. So I think at a high level, these are our functional requirements. So let's put these right there. And I guess another key element of system design is the non-functional requirements. So we'll put that. How shall I organize this? Cool. We'll put that there. And then we'll have another color for non-functional requirements. So non-functional requirements. So, I mean, if you've been reading my posts, you know what I'm talking about here. So things like high availability. So if I'm hungry, delivery should be available. So there are certain times in the year where that are peak times. So imagine Champions League finals on. A lot of people don't want to cook, so the app should be highly available. So especially during peak times. And I guess another functional requirement is something like low latency. So like what I mean by that is when I'm choosing a rider. So let's say a user has placed an order and the restaurant has accepted it. There should be low latency when choosing a rider, basically. So rider assignments and tracking. Cool. Another functional requirement. What would I say? I think it's scalability. I think when it comes to something like Deliveroo, once you've run enough promotions, once you've burnt through that VC cash and you've got a lot of users, your systems should be able to handle it. Especially, I mean, I think Uber Eats used to run these promotions where it's like buy one get one free, but the restaurants are not actually losing money. It's all covered by Uber Eats. So that's to try and acquire new users. And so when you acquire all these new users, your system should be scalable enough such that it can handle those users and not crash. Because if it crashes, they'll just move to a different one. So this is actually very important because there's so many different options. There's Deliveroo, there's Uber Eats, there's Just Eats, those are the ones I know. So yeah, millions of users. What else is there? I think we'll keep it at that. So these are our main functional requirements. So our system should be highly available, low latency, and scalable to millions of users. So we actually make this a different color though, to make it green. I think the one thing I wish Excalibur had is like a color picker. Oh, they actually do have it. Nice. Shall I shall I find the hex code of the Deliveroo logo? Nah, that's doing too much. That's going above and beyond for my audience. We're not quite there yet, but we'll make this a different shade of blue though. Yeah, that looks nice. Say three. Yeah, cool. So these are our functional and non-functional requirements. So now, given this, we should be able to flesh out a few of the microservices that we need, and then from there we'll be able to talk about the trade-offs and a few other things as well, as in like when we choose a database, why we're choosing a specific database over another one, and yeah, cool. So, how do I want to do this? Zoom out a little bit. I think that's cool. Put these to the side as we no longer need them. We can move the board over like this. Cool. So let me draw a user. That is way too big. Stroke width. Yeah, that's fine. Cool. So here's our users. This is a hungry user who's on our Deliveroo app. So they can connect via a mobile app or a web client or something like that. And obviously, they're going to connect to an API gateway. Actually, because I want to paste this into my live stream overview, I'll actually draw it nicely. So we'll call this our API gateway. How can I write horizontally or vertically? Sorry. API gateway. So essentially, the API gateway acts as like a load balancer. Also handles things like authentication, rate limiting, and a few other requirements that we usually need. So that's our API gateway there. Cool. So what does that API gateway connect to? It's a bunch of microservices that talk to each other via message queues or APIs. So let me just take a sip of water. So I guess the best way to actually explain this is through going through our user flow. We'll be able to understand the microservices that we need. So users can browse restaurants and place orders. So obviously, we're going to need like a user service. We'll call this the user service. User service. Can I not make the text smaller? Okay, cool. So our our user service stores things like who our users are, and any information that we need about them. So if they decide to store, I don't know, some payment information, preferences, that's all in our user service there. And that obviously connects to like a database that stores all our information. We also need a restaurant service. So this stores information about restaurants and handles everything to do with the interface between Deliveroo and users, and restaurants. Restaurant service. We're gonna want an order service. So this is the microservice that handles our orders, and yeah. Also for our other functional requirements, let me scroll over a little bit. Users can browse restaurants, place orders. So users can browse restaurants, place orders, riders can receive. Okay. Cool. Restaurants receive orders, accept orders, prepare food. Okay. Riders can receive orders, pick up food, deliver it. Real-time notification. Okay. So I guess we're also for 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 real-time tracking for users and riders, we're also going to need some kind of location tracking service. So let's also put that in there. And we're going to connect all of these when I'm talking about the different flows and how they all talk to each other. So location tracking service. We're also going to need something like a payment service to handle our payments and communicate with like Stripe or another payment provider. These are a lot of services going on. But yeah, obviously these are going to be containerized and on like a scaled group on like Kubernetes or something. So yeah, payment service. What else do we need? Okay, cool. I think we'll start off like this, and we'll talk about how all of these connect to each other. So I guess we'll talk about the order placement flow first. So our first functional requirement, users can browse restaurants and place orders. And then from there, we'll see what else do we need to add to this high level diagram to be able to actually execute our first flow. So the actors involved in the first functional requirement would be our users, our restaurants, and obviously our platform backend. So how this would work is the user would open the app, and I'd say the restaurant service would fetch a list of restaurants filtered by location, filtered by like cuisine, popularity, delivery time estimates, and then display that to the user. But obviously, it's not going to fetch it from a database. It's probably going to be cached for performance reasons. And yeah, so we're obviously going to need a cache. So, or like a CDN. CDN. Cool. So that's our first flow. But let's actually move all these microservices out the way. And hopefully, when we talk about our different flows, we will be able to see how all these microservices integrate with each other. So, but let me just recap that first flow, and then yeah. So our user will open the app. Our restaurant service will fetch all the restaurants that we need from our CDN, and our CDN will probably get refreshed over time from a database. This connects like this. Boom. And I guess once the user has chosen something, oh, how do I move this? So once the user has seen a restaurant that they like, they now want to place an order. So the user selects an item and taps order, and then the order service would get involved. So I think the order service would need to check if like the restaurant's open, is the item in stock, and that would then invoke the payment service to actually pre-authorize the amount, number one. And then it would also, once the payment has gone through, create a new record in the order database so that we can keep track of all the orders. And yeah, so I think so this also needs its own database. So it's going to be heavy on the writes. So we're going to need something like a relational database or So P-SQL or MySQL, that should work fine, because obviously when we're placing orders, transactions are important. So I'd say they need to be ACID compliant. So how do I want to draw database? Oh, do it like this. Okay. Let me just recap that flow. So the order service. So once the user clicks on order, the order service will check the order first. So check if the restaurant's open using information from the restaurant service. So these two will need to be connected. And then it also needs to interact with the payment service to actually make sure that the payment has gone through. And then once the order has been confirmed, we store it in our database. And then once that's been confirmed, our order service would then need to send an event to our, okay, cool. We need a message queue. Yeah, so essentially once this has gone through and the order has been confirmed, we then send a message to like a message queue that the restaurant service is subscribed to. So yeah, we store it on that restaurant's topic on the message queue, and then that gets consumed by the restaurant service to then send it to the actual restaurant. So I guess, yeah, I think that makes sense to me. So we'll have a message queue like this. Let me delete that. I think this system design diagram is going to get very messy very quickly. But yeah, for those of you who are just going to watch the post live recap, hopefully it should be cleaned up by then. Oh. Okay, we'll call this message queue. So that will send a message to the message queue to then be consumed by the restaurant service, which will then notify the actual restaurant that needs to cook the food. How do I want to do this? I think that makes sense to me. Okay, cool. So essentially, once we've notified the restaurant, okay, let me. This is a restaurant. To make it obvious, I'll put open. Okay. So once the user has placed the order and the payment's gone through, we store the order in our database and then send a message to the message queue, which then gets consumed by the restaurant service, sends a notification to the actual restaurant itself. And then I guess once the restaurant has been notified and they've accepted the order and they're cooking the food, that's when we need to start getting the riders involved. So who's gonna pick up the food and actually deliver it to our users? So yeah, so I think we need um, some kind of microservice that handles delivery matching and rider assignment. So I think that needs its own system. That's something I've actually forgotten. So I'm going to draw that as well. I'm going to call it rider assignment. I'm going to put that here. Actually, for now, we're going to delete those. I'm going to move this to the bottom. I'm going to zoom out a little bit. Um, rider assignment. Okay, cool. Okay, cool. I think we need another message queue. Actually, we could have. Okay, so once the restaurant accepts the order, that's when they so that's when the action of them clicking accept would then send an event to another message queue. So the event gets pushed to this rider assignments microservice to then essentially be notified to start looking for new um, start looking for delivery drivers, and then from there it will assign a driver and then invoke the location service that that will then send notifications to the user and to the restaurant about the location of the driver. Cool, let's break that down. So I guess this also needs to connect to our message queue. Okay, so this is user, because now we have another actor involved. We're gonna need to draw them as well. So this is user. This is actually quite a complex system. And when I was thinking about doing this live stream before, I was like, oh yeah, Deliveroo shouldn't be that hard to design. um, rider. I'm gonna draw a little car. Cool, that does the trick. Um, let's put this guy here. So I guess, how does their flow work? So the rider goes online through the app, and once the okay, we will need their location to be continuously sent, because when I think let me think about this. Cool. So our rider, what we care about when we're doing rider assignment is where they are. I think the vehicle type also matters, and their current status, as in, are they doing a delivery right now? Are they available? Are they assigned? Are they delivering something? So that our rider assignment service will then have this information and be able to determine who the best rider is for that particular job. So we're going to need a location service is that is getting their location data. Where is that typing? So yeah, a rider service that is continuously getting their location and then using that information. We're gonna ingest that and store the coordinates in an in-memory data store like Redis or some kind of geospatial database like, I don't know any off the top of my head. Location service. Cool. So our riders are continuously sending their location to the location service, and then rider assignment will then connect to this location service to be able to get riders in a specific location based on the user who placed the order. I think that makes sense. So over here, that will be connected to some sort of data store like Redis or some kind of a geospatial database. So yeah, so something like Redis. Why am I writing that like this? Okay. Whew. This is getting more complicated, and like the more I draw, the more I'm thinking about other things I need to consider. All right, cool. So let's talk a bit more about the rider assignment over here. So the system will talk to the location service to then determine candidates based on a few things. So things like proximity, estimated time of arrival to the restaurant itself, the current workload. So like imagine like a rider is currently doing a delivery, and on their way they could also pick up some other food and make that same delivery along the way. And then obviously the riders score. So if they're a good rider, they'll be prioritized, and if they're not, then they won't get the same priority as other uh, as other riders. So how they probably do that in rider assignment is they could have something like a rules engine or like a weighted scoring system, or yeah, those are the two things I can think of off the top of my head. So the rider assignment will be like a rule based engine or like a weighted scoring system that will take location data and other information about the rider to then assign a rider to this particular delivery. So when okay, so riders also need to accept jobs. So I guess for that we can have two different flows. We can either okay, let me think about this. So we can have a system where the system auto assigns the best match. So imagine you're the driver. You get sent a notification saying you have a new delivery to do, and then the rider receives the job and accepts or rejects. And obviously that has a time limit. So if they don't accept or reject within a certain time frame, then we send it to someone else. And then the other way is if we send this this particular order to all riders, and whoever accepts it first gets the job. And that will be slightly simpler, but that could lead to like an unfair distribution because certain riders will just be like spamming the accept to make more money. So that won't be favorable. So yeah, that's basically how the rider assignment will work. We'll either send notifications to the riders themselves, so we need a notification service to send to everyone. Basically, everyone connects to this notification service. Why is it not typing? Notification service. And yeah, everyone connects to this. So yeah, this service everyone connects to. So like riders, users, and restaurants will all be connected to this notification service to get notifications about particular orders. And then I guess from there, we also need live tracking service. So this is also our location service. While the user is actually doing the delivery, they will constantly be sending their live location so that we then know where they are and how long they have left. So I think that I think I've covered most of the things in the system. Let me just take a look at this and think about it a bit more because this is starting to get a bit messy. So user places the order and API gateway restaurant service that sends it to that uses information from the CDN to populate the restaurant. Okay. And then once they place an order, goes to the order service and payment service that sends back, and then it gets stored in our database. And then once an order is confirmed, it sends it out to the message queue. Cool. I think at a very high level, this is starting to take shape. Yeah. Okay, let's talk a bit more about, I think, real-time tracking and how that works as well. So I think the stakeholders involved in this would be the users watching their food move. So once the rider has their food, the user would be interested in knowing where it is. The restaurants would also need to know where the rider is so that they know like when to get the food ready. And yeah, I think those are the two main stakeholders. And how we'd actually do this is using a WebSocket connection. So when a user opens the order screen, the app establishes like a WebSocket connection, and the rider starts streaming their location, the ETA update, and delivery status, which then gets sent to the user and displayed on their UI. Yeah, I think that's how we'll deal with that. And obviously, scaling that is pretty easy because the WebSocket connection will be stateless. So yeah, we can scale that horizontally. Yeah. I'm trying to think if we've missed something. Yeah, cool. Cool. I think at a very high level, this is probably what something looks like. I think what I've explained. So let me move that there. So I think so far what I've explained verbally is not fully encapsulated in this drawing, but I guess if I had more, if I was a bit more organized, I would have drawn this before actually doing the live stream. But I guess now we'll just talk about the different like trade-off and design decisions so that you can understand why certain things get chosen over the others. So over here for example, why did I choose Redis? Um, because when we're streaming streaming the rider's location. We need to be storing it somewhere that's accessible and fast, because when we're displaying it to the user, it needs to be easily accessible. And obviously, the architecture here is microservice, because we're trying to implement some sort of event-driven architecture, so that we can scale our services independently and they're not tightly coupled. So that's why we chose to go with a microservice approach. Yeah, because obviously monolith wouldn't really scale well with this, and our key our key non-functional requirement here was scalability to millions of users. So I think having a microservice approach like this would work, and yeah, with scaled jobs in Kubernetes, these would all scale independently. So that's a plus. Cool. I guess anything else I need to discuss with this? I think at a high level, I think this encapsulates what Deliveroo is trying to do. If I had more time, I think I would have gone into a bit more detail about like the schema design of certain databases involved here. But yeah, obviously, like a rule of thumb is, if the service is read heavy, use NoSQL. If it's write heavy and you need ACID compliance, then uh, use a relational database. But yeah, this message queue here is to scale all our services independently, and when we send an event, so let's say our user has placed an order and the order has been confirmed, we then send an event to the message queue here, which then gets consumed by the restaurant service to then notify the restaurant using the notification service. And yeah, I mean, for all the real-time information of things like location of the rider, we'd use things like WebSockets to send that to the user. And I think at a high level, this is everything. And then obviously for the actual Deliveroo team, we'd used like tools like Grafana or like Prometheus for for uh, for things like monitoring and logging. So yeah, that's how that would get handled. And then something like like an admin dashboard for our users here would be like some kind of dashboard in React, and that would connect to our restaurant service here, so they can update their things like menus and stuff like that. So yeah, I think at a very high level, this is how it works. And yeah, I think if I was to do a system design overview again, the I'd get the this system design diagram done before. So yeah, that's my bad. But yeah, I think I'm gonna end the live stream now. It sounds like I'm getting a bit of a cold, so I'm gonna go try to sort that out. And yeah, if you guys enjoyed, I'll see you next week. And oh no, I actually won't be seeing you next week. I'm on holiday, so live stream the week after. And yeah, I guess something that was mentioned earlier, the winner of the first month's giveaway is Mohammed Abbas. I'll be messaging him personally, and yeah, I'll see you guys in 2 weeks. Bye.